question is support seminar 2026 structure, question number 4. So these apparatus are used to determine the internal resistance R and electromotive force of a dry cell. The question is, draw how you connect this apparatus properly. This is the dry cell. Okay. So resistance, all the resistance should be connected in series. Voltmeter in parallel with the dry cell, right? And ammeter in series. So by keeping that in mind, we can connect. Right. This is the tab key. Right. So all the connections are made. This is how we have to connect. So ammeter and this resistance value should be connected in series, right? And voltmeter should be parallel with the dry cell, right? So in a circuit symbol diagram, we can say like this. This is the dry cell, right? Voltmeter should be connected in parallel. This is the rheostat, and the standard resistance is here. Ammeter is here. Tab key is here. So this is the circuit symbol diagram is this one, right? This ammeter is a milliammeter, and right, we can say this is a milliammeter. Right, and the range is also given here, right? We can see minus 0.2 ampere to 0.05, right? Up to this range we can take the reading. Okay. Right. Generally, right, the ammeter to measure internal resistance of a dry cell, right? We are using the ideal ammeter, which has zero zero resistance. Okay, so this is okay. Second part, consider the electromotive force of a cell E, internal resistance R, voltmeter reading V, and ammeter reading I. A. Write down a relationship between above parameters, rearrange it to plot a graph. As we know, right, when a cell is providing an electrical current, for example, right, this is cell, right, when a current I is flowing through it, right, and the terminal voltage is V, electromotive force E, and internal resistance R, then we can say V, the terminal voltage is equal to E minus IR. Okay, terminal voltage is equal to E minus IR. From this, we can rearrange this in a way to plot a graph. So V is equal to minus R times I plus C. E is a constant value, R is a constant value. So this is in the form of Y is equal to minus mx plus C, minus mx plus C, right? Now, following are the readings obtained by us when from such an experiment. Plot the graph on the graph paper given below. So we need to plot the graph. So the format of the graph is y is equal to minus mx plus c, right? So by keeping this by keeping V in y-axis and I in x-axis, we can plot a graph, right? From the graph, we can obtain internal resistance as well as the electromotive force. Internal resistance can be found using this gradient, and electromotive force can be calculated using this intercept. So from the graph will be in the format of y is equal to minus mx plus c. So from this we can find r. R is gradient, difference of y or difference of x. So we can find r, right? D part, determine the electromotive force of the cell. Electromotive force is intercept. So the format is something like this. So from the intercept we can find the electromotive force, right? So that also okay. So the next question is why it is important to use the tab key. Tab key that will work when we push on, right? When we release the hand, it will automatically disconnect. So whenever there's a necessary for the current to pass through the circuit, we can press. Other times we can release the hand finger so that the current will be disconnected. So, due to this, we can prevent the cell to discharge. So how we can answer this? To pass the current through the circuit, to pass the current through the circuit only when readings are taken. Readings are taken, right? And disconnect automatically in other times. In other times, okay. B, you are provided with 10 and 50 ohm standard resistor. Which one do you use for R? R is a standard resistor, right? If you use 10 ohm, then what will happen? The resistor is connected in series. So what will happen? If you use the 10 ohm resistor, there will be a maximum current. 50 ohm, if you use 50 ohm, then that will reduce the current flowing through the circuit. So 10 ohm is preferable. 10 ohm standard resistor, right? The reason is when 50 ohm resistor is used, right, the maximum current flowing through the circuit reduced. Circuit reduced. C part, explain why it is important to use R having being provided with a 100 ohm rheostat too. Right, we have rheostat. In addition, we have a standard resistor R because when the resistor rheostat value is set to 0, then if the standard resistance is not present in the circuit, what will happen? Then there's no resistance on the circuit. That means high current will flow. Then that will quickly discharge the dry cell. So what we can say for C, to prevent the dry cell dry cell discharging when the rheostat when the rheostat short circuited, when the rheostat short circuited. D part. What part of the circuit more suitable to connect the tap key? K. Right. That means where we have to use this tap key. That's the question. Right. Since we have to disconnect the current, R should be connected between the ammeter and the part of the rheostat. Right. So, sorry, that tap key should be connected between part with rheostat, right, R and ammeter, right. E, state the reason for your answer in third D. Right, suppose if the tap key is connected with the circuit part of voltmeter and the dry cell, then the resistance caused by the closed switch, right, would be included in the calculation as the internal resistance of the cell. So that's the reason. So if the tap key was connected, to the circuit part with voltmeter and the dry cell, the resistance caused by the closed switch we can say would be included in the calculation. As the internal resistance of the cell.